Today we are doing the second lesson on probability, and we're going to make predictions. We're going to use probability to be able to make predictions on various events. So to make predictions with probabilities, you take the probability of the event happening and you times it by the number of trials, or the number of times you're going to have something happen, okay? So this probability is the probability of the event times how many times you did it. Okay? All right. Looking at this first example, it says according to game rules, the probability that a bottled water cap can be redeemed for a prize is 1 out of 24. That means that theoretically, in theory, if I have 24 bottles of water, I should have one that I can redeem for a prize. Let's say a store stocks up 500 bottles of water. About how many winning ones should we expect? How many winning caps? So you do the probability of it happening, that's 124, times how many I have. 500. Now do old school math. You never know, don't do a calculator math, do old school math. You never know if the MCA will let you use a calculator or not, so you always want to be able to go without first. I cross-simplify. I don't know what they share in common, but I do know they're both even, so the first thing I always do is half them. That's always my first. I see that they're even again. I half them again. And now I don't know what else goes into it. So it would be top times top over bottom times bottom. I think that's about 20.8 if I remember right. That part I could use my calc for, do old school division. So I would say I can't just magically appear another bottle of water. I would say about 20. Here I would round down because I don't have 501 bottles of water. Suppose that the probability that a bottle has a winning cap is only 1 out of 40. Well, if I stock 500, how many should I expect to receive? Same strategy. 1 out of 40 times, what, 500. I love zeros, things that end in the power of 10, because I can cancel that out quick. They're both even, I can half them. 25 halves. 2 goes into 25, how many times? 12 and 1 half. 12.5. I would say around 12. Okay, so I would say there it would be around 12. In a random survey, surveys are experimental probability, 36 out of 60 people said they plan on voting for Mahowald for president. It's me. In a town of 1,500, how many people would vote for Mahowald? Okay. No. My kids would vote for me, and so would my husband. Okay. Okay.
I'll vote for her twice.
All right. So I need to find the probability of the event happening. So I say the probability of Mahowald. So probability Mahowald. It's going to go like that. Is 36 out of 60. Okay. 36 out of 60 are pretty big numbers. I'm going to simplify it a little bit. 18 over what? 30? Again, can simplify it. 9/15. Oh my, I can simplify it. See how I simplify it? I don't follow, I just keep chopping them down until I can't do it anymore. What would this be? 3/5. So the probability of somebody voting for me, according to this survey, is 3/5. That means for every 5 people, 3 say, go Mahowald, okay? say I have 1,500 people. How many people would I expect to vote for me? So I'd say the probability that they vote for me times it by the amount I'm looking at. What's that? 300? 900 people. I think I win. Okay? I think I win. She has the majority.
What if she's against
No, I would never want to be president. My knowledge is very math-centered. I would not be a good world
No,
leader.
that'd be good for every
Every duck.
At an auto factory, three out of the 100 cars have a minor defect. If the factory produces 600 cars, about how many are likely to have? We'll just call this a minor defect. Okay? So I need my probability that it's a defect is 3 out of 100, right? So probability that it's a defect times the total number. $18 cars I can predict are going to have a minor defect out of 600. Okay, using theoretical probability, if we toss a fair die 211 times, how many times would you expect to get a number greater than 4? So here I have to figure out the probability at first. So probability bigger than 4.
2, 6, right?
Yep. So I can get a 5 or a 6. So that's 2 out of 6, which is 1/3. That's my probability. Yep.
How would you know whether to count 4 as one of the numbers or not count?
Because if it said at least 4, at least means include it, but it says greater than 4. 4 is not greater than 4. 4 is 4, right? So you have to just know that. And you have to know if it says at least means to include the number. All right, so 1/3 times 211. 3 goes into 21 7 times. 70 point something? 3. So 70 and a third. So approximately 70 times. Okay, we need one more heading. And I don't know where you want to put it, but your homework for today talks about something. It's a pre-teach to tomorrow. Tomorrow we are learning about compound probabilities. In this making prediction, there is compounds involved. So I just want you to quick write compound probability. I'm going to tell you how to do it. I'm not going to give you too much of the formal lesson. Compound means more than one probability. An example would be rolling 2 die. I have a probability of one and a probability of another, and they're compounded. Okay? So what you do is you do the probability of one. Let me just write the word probability of one. You times that probability by the probability of the other one. That's how you do compound probability. So the probability of one event times the probability of the other is equal to the probability of both. Okay?
All combined.
Yep. For example, let's say that you roll 2 die. Roll 2 die. Maybe I should say if you roll.
Yeah.
If you roll 2 die, what is the probability that they are both heads? Okay, what's the if you dang it. Okay, let's say both 7. Just kidding. My goodness, 3. Let's say 3. If you roll 2, okay, there. Now it's making sense.
1 in 37.
Okay, so if you roll 2 die, not dip, die, What is the probability that they're both going to be 3? Okay. So it would be the probability of one of them being 3 would equal, I don't want to break it up like that. I just want to break it up like the probability of 1 is 1/6. Probability to get 3 is 1 out of 6. The probability for the other die to get 3 is 1 out of 6. So the probability for them both to be 3 would be 1 out of 36. Then you can use this to make predictions. Okay? So you're gonna do the same strategy. There's just a couple questions that I saw last hour about a cross compound. And it's usually with die or coins.